Time and Motion for class 7th. We use the word time so often in our everyday lives. Why do we need to measure time? In every civilization, there has been evidence of people keeping track of the passage of time. Today, we measure time for a variety of applications. We need to know when a train or a plane will arrive, how long a TV program or a movie will take, the amount of time a computer will take to perform an operation, and so on. The list is endless. Time can be defined as the period between two events. This is a beautiful sunrise and a beautiful sunset. These can be taken as two events. The period between a sunrise and a sunset would be the time between these two events. Any object that is moving is said to be in motion. In order to measure time, we need a motion that repeats itself in equal interval. Such a motion is called periodic motion. Let us look at this image. Can you see the periodic motion? Do you know what this object is called? Yes, it is a pendulum. A small mass that is suspended from a fixed point and allowed to swing freely under the influence of gravity is called a pendulum. When the bob moves from one position and comes back to the same position, it is said to have completed one oscillation. In the figure above, if the bob starts at point A, then moves to point B and C, and then comes back to point A, it is said to have completed one oscillation, while the time taken to complete the oscillation is called the time period of the pendulum. Let's perform an experiment. Take a string of 30 cm length, tie one end to a handle while tying a stone to the other end. Displace the stone and let it oscillate, and then use a stopwatch to note the time taken to complete 10 oscillations. Divide the time taken for the oscillations by 10. This gives the time period of the pendulum. Repeat the experiment many times and compare the value of the time periods obtained. The time period is same in each case, hence proving the constancy in the time period of the pendulum. By studying the oscillations of the pendulum, observations can be summarized as follows. The time taken for a pendulum to complete one oscillation does not depend on the extent to which the bob is displaced. The time period does not depend on the mass of the bob, but within reasonable limits. The time period depends on the length of the string used. Greater the length of the string, greater is the time period. This means if the length of the pendulum is fixed, its time period is constant. This was a wonderful discovery. Scientists began to build new clocks based on this property of the pendulum. Measurement of time. Look at this toy truck. Let's say it covers a certain distance. Now, if someone asks you the speed of this truck, how to measure the speed? You need to know the time that it took to cover the distance. But how do you measure the time? In ancient times, people used to measure time using natural phenomena like position of the sun, length of the shadow, which were however not very accurate. Then came the sundials and the hourglasses, and finally modern devices like clocks and watches to measure time. So, you have learned the importance of measuring time. You have also learned about some time measuring instruments. Next, we will go on to slow and fast motion. Objects may travel fast or slow. When we say a body moves fast or slow, we refer to its speed. Speed of an object is defined as the distance traveled by it in unit time. The SI unit of speed is meter per second. Speed of a body in motion is represented by the given relation. Speed equal to distance covered divided by the time taken. In the example of the toy truck, if we say that the distance covered equal to 100 meter and the time taken equal to 1 meter or 60 seconds, then speed can be calculated by the above relation and would be 100 meter divided by 60 seconds equal to 1.67 meter per second. In practice, very few objects travel at a constant speed for long. Your school bus may speed up and slow down many times on the way to school because of heavy traffic, traffic signals, etc. This is an example of non-uniform motion. In this case, the speed can be determined in terms of its average speed. Average speed is defined as the total distance traveled divided by the total time taken to travel the distance. When we talk of a speed of an airplane or a car, we use kilometer per hour. An instrument measuring the speed of a vehicle is known as a speedometer. You could perform an experiment to calculate the speed of a moving object. Ask your parent to take you for a drive at a constant speed in a car or scooter on a not too crowded straight road. Next, ask your parent to secretly note the speedometer reading while you note down the kilometer reading every 1 minute. And getting back home, calculate the average speed and compare your result with the speedometer readings. Are they the same? You need to check that out to know the answer. A vehicle does not travel at a constant speed through its journey. If we note the distance at equal intervals of time traveled by the object, we will get a clearer picture of its speed at different points of time. The data of the distance traveled and the time taken can be represented in the form of a graph known as the line graph. It is created by plotting a series of data points and then connecting them to form a line. Here we have taken time on the x-axis and the distance on the y-axis. Other commonly used charts are the pie chart and the bar graphs. Here we have a pie chart representing household expenditure, while the next figure is a bar graph which represents the household expenditure over a 6-month period. To wind up this lesson, we will examine a distance and time graph and summarize the observations. The steepness of the slope of the graph gives us the speed. Speed is greater if the slope is greater. Speed is 0 if the graph is flat. If the vehicle moves at constant speed, it covers the same distance in equal intervals of time, and the motion is called uniform motion.